possible. Okay, acceleration. What we do? We install, as you saw, we configure. It's just one contiguous recording. We just divide it on the parts. Install, configure, start VM without acceleration. IO meter there, 70-30 read-write ratio, random read-write. Check performance, start acceleration without restarting virtual machine. Populate cache, check performance, and after that you will see the comparison of results. Okay, virtual machine, we start virtual machine. 70-30 workload, perfect, 70-30, start. It's not our GUI. 70,000 IO per second, pretty much, 8 hard drives. And start acceleration without stopping virtual machine. This is very important. No server reboot, no stop virtual machine. This virtual machine, this virtual disk we want to accelerate. Done, acceleration is done. Actually we programmatically access SPBM. Attach will done, and after that we populate cache. Number of read cache hits is small number, but writes, obviously it's write back cache. It goes everything, it goes to on SSD. We populate cache, and while we're populating this, number of read caches goes up, performance is up, and you will see that we have just single SAS SSD, which is about 90,000 IO per second for this workload. We have pretty much everything what we can get from single SAS SSD on this server. Now, if you think about, it's 13 times faster. If you think about scale out, look at everything else from scale out standpoint of view. So Rich has one of his favorite slides. Each host for 70-30 having active data in a cache, you can easily have between 100 to 200,000 IO per second. If you have 10 hosts, and because it's completely scale out, you actually can pretty much multiply a number of hosts. It's completely scale out. So if you think about price of the storage that you can get million IO per second, let's say, it's pretty expensive storage. So we can save a lot of money for the customers, taking money from the storage if they use our software. vMotion, while we're running this with acceleration, this benchmark 70-30, let's start vMotion. Write back acceleration for this virtual disk, this VM, this virtual disk. From host 1 to host 2, vMotion. Okay, this is progress bar, vMotion progress bar. Now let's see on the performance. It's real-time recording. It's pretty much the same, a little bit low, below 85,000. After that, very short glitch, and after that we are back to same performance. So
the glitch is 3 to 5 seconds?
It's a little, very small, yeah, very small. Something like that. So as you can see, everything already accelerated because it's write back caching with replication. High availability. For write-through cache, high availability actually it's pretty much given, right? Data is data is here, and if host is down, SSD is down, we just switch to whatever we have on a backend storage, on the data store. If this is write back, situation is much more complicated. We cannot just say, okay, use this data because data sitting in a cache in a host. So there are 4 situations that we have to handle properly. This and this is pretty much the same. SSD is down, host is down, link is down. If SSD is down, we absolutely do not want to bring down the host. No way. Because if you bring the host down, the damage for the data center much bigger than glitch and acceleration because of SSD. You know that SSD is down, we have 100 virtual machine running here. Let's say 100 virtual machine. No, don't do it. It's better let them run a little bit slower, whatever slowly, but keep host alive. But we have data here. How we recover data? We copy data from here to here, because second copy is here. How to differentiate? Is it a host is down or link is down? Because this is a split brain, right? How to do this?
Well, usually you use a witness.
We don't need it. If our demons that are running here, any suggestions?
Now you got Justin's attention.
Any suggestions? We have 8 minutes. Any suggestions? 1, 2, 3. Sold, right? Actually not. That's what we do. If this guy, let's say VM is running here, replicating data here, and suddenly our link connection is broken. This guy tries to open virtual disk for VM which is running here, because this is a master, this is the owner of this virtual disk, this is a slave. This guy tries to open virtual disk. If it can, host is dead. If it's not, it's alive. It is a split brain. Because it is a split brain, we start flushing here and here, both nodes switch to write through mode, period. So, existing cluster services, which is basically...
Yes, you're basically using the backing store as your witness.
Plus sidecar with our attributes that we have everything. Yeah. We know everything.
Yeah. So you don't need to provide a witness because you've already got it handy.
Exactly. So virtual machine moved somewhere else. If host is down or link is down, virtual machine will move from here to here. If host is down, it's just suddenly is surprised. Let's say fell over. It is fell over. Machine moved to another host. This host try to start this VM. As a part of open, because we have open event, in a part of open, we read our persistent attributes and we see does this VM has an owner? If it has an owner, it has dirty data. Ask this guy, because this immediately start flushing this in behalf of this host. Stop flushing, close virtual disk, I close virtual disk, start VM. Actually it will be, open will fail because of reservation. We have this reservation and after that we return with reservation. After that we communicate to this host,
then close
virtual disk, cancel reservation, reopened, succeed, but both daemons, here, this daemon and this daemon, they know already that, an instance as well, they know already that data is there. And we start what we call remote flush and spot flush. Remote flush, this guy that push data through this node to write it here. Spot flush, if out of order virtual machine which already started on another host needs some data, say, give me this data, what we call spot flush it.
Right.
Give me this data.
Okay. So you don't pass it directly, you send it through the backing store.
We cannot through the backend store because virtual disk is open already here. We must do it through them.
Okay.
We cannot do it here.
Yeah.
So we cannot do it from here because we close virtual disk here, reopen it here, and now this guy cannot write here because virtual machine opened this already with write reservation. We cannot write it here. So this is a fragment of our GUI. If SSD is down, what we have in this host, SSD is down, host crashed, VM in a warning state because we switch from write back to bypass mode. This host in a cache is okay, but warning about all VMs which are running here, because VM, instead of write back cache, it writes through cache. So that's basically how it works.
On an SSD failure, do I get some kind of signal that I can use to start DRS?
We don't have in this moment, VIO doesn't provide for us any information about it. It's we talk about it with them.
Because that's the kind of thing you want to deal with in the orchestration layer.
Absolutely right.
Okay. Yeah. Next time.
So the only what they give us, actually it's not in the list of these events, actually we can call them and we can tell them, you know what, on this host, don't start VMs if they have virtual disk accelerated.
Okay.
And they provided this API. It's up to us how to recognize SSDs down, or maybe daemon completely, just we cannot restart daemon. Some fatal error we cannot recover.
With your code? Those things don't happen.
We have one bug. Yeah, so that's what we have to, actually they have 3 minutes.
So
I'm done.
I have a quick question. You might have answered this already. Apologize if you did, but
please do it.
does this work with any SSD?
Unfortunately, any
It was-
SSDs. Any SSD, any data store,
Excellent.
whatever.
Okay, that's what I thought you had said, but I wanted to clarify. Thank you.
I see.
For some reason, it has to be vVol aware storage.
Back to the very beginning. Not at all. It
That's
is-
the
it is whatever.
VM. We're using vVol to mean two different things.
It's a protocol.
Oh,
You can have regular Sun, VMFS running here.
But Justin?
But
Imagine how
anyway,
much material I have for my session tomorrow.
from virtual machine standpoint of view, it is a virtual disk protocol. And they intentionally, they use virtual volume as a name for protocol, which is, as we said in the very beginning, confusing.
Right.
yes.
But it is a common presentation with VMware, and we wanted to,
And you have to use their terminology. Yeah.
yeah.
Was there some point in there that you enabled that storage policy on each of the virtual machines and each of the VMDKs?
Yes, of course. You didn't see in our GUI, we have a search. You have a filtering. For example, you can start acceleration for all virtual machine and all
That's
virtual disk.
programmatic. You don't have to do that in the vSphere web client.
Completely programmatically. It is a filter, and you can filter based on VM name, virtual disk name, host type, but usually it's virtual machine and virtual disk.
And do customers typically just enable it on every VM, or do they try to use some system to pick and choose which VMs need the
Usually
cache?
they pick.
Okay.
Usually they pick. And that's why virtual disk granularity, actually virtual disk granularity is so good. If you have database, we have 1 minute. If you have database, you have actually the choice to accelerate log, to accelerate log and your tables, log and tables and indexes. You have full just freedom to do this.
Does SanDisk provide any tool or make any recommendations as to which VMs and which VMDKs would most benefit from the cache?
SanDisk doesn't provide this. According to our experience, yes, we can give some recommendations. But there is a third-party companies that actually can provide this important information for users. Good question. Makes sense. There is a company exists already.
Cool. All set?
17.
You have 17 more seconds. Anybody else have a short question?
Okay, let me tell you very good news. VIO works. It's for VMware. It's a good design.
But I thought you designed it.
They developed. We co-designed. No, I can tell you.
Sergey just pointed out when they were being stupid.
Yeah.
It's a good design.
We just asked them to do something. It's a great team. It's absolutely fantastic to be partner with VMware. Thank you.